Good day I bid to all. My name is Mythili Nadarajah with Matric Number 190877 and I'm currently doing my Bachelor of Chemical Engineering. This is my final year project presentation, IoT of Water Quality Management and Optimization of Effective Microorganism. So before I carry on, let me tell you the preview of the presentation. Firstly, I'll start with the introduction, then problem statement, carry on with the research objective, methodology, results and discussion, conclusion, and I'll end it with the recommendation from the study. Firstly, I would like to start with the introduction. Drastic urbanization and industrialization have caused a detrimental effect on the water body, especially natural water systems such as rivers, lakes, and ocean. Hence, the quality of water has to be monitored regularly by measuring the necessary parameters such as pH and DO. The monitoring system has to be efficient and reliable, which is why real-time monitoring system is recommended. This study also highlights the background of effective microorganism and the use of it in various sectors, especially in river water treatment. Thus, optimal usage of EM in specific water condition will be analyzed. Next is the problem statement. First is the natural water resources. The resources, especially rivers, are being polluted vastly, even though 90% of 100 rivers in Malaysia supply raw water, and unlike effluent from industries and wastewater treatment plant, there is no standard for water condition in rivers. Secondly, the traditional water monitoring system is time-consuming, unreliable, and inefficient. Thirdly, the methods to enhance the water quality are either costly or non-eco-friendly. There are three main objectives for this research to be achieved. Firstly, to develop an intelligent sensor network to measure four parameters of water quality, which is the pH, electrical conductivity, EC, dissolved oxygen, DO, and oxidation reduction potential, ORP. Secondly, to develop a network that integrates the Internet of Things, IoT, to the intelligent sensors network of the four parameters. Finally, to optimize the use of effective microorganism, EM, in water quality enhancement by using the intelligent sensor network to monitor the significant parameters. So there are four parts of methodology for this study, which is development of sensors network, which includes the calibration. Secondly, to integration with IoT technology. Thirdly, sample taking and monitoring. And finally, optimization of effective microorganism. For the first two parts, Arduino IDE and ThinkSpeak softwares are used. First, the sensors are tested and calibrated to ensure that it is functioning well enough and connected to the Arduino Uno, which is the microcontroller of the system. Next, the Wi-Fi module ESP8266 is connected to the Arduino Uno to receive the strings of data, which are the measurement using the sensors. Then this data will be displayed in ThinkSpeak website using the IoT technology. The third part is obtaining samples from study area for 13 bottles of 1.5 liter volume and added with different concentration of EM1 and being monitored using the system. The fourth part is analyzing the results that are obtained from the monitoring system and decide which is the best EM1 concentration for the sample's quality. So let's move on to results and discussion. Firstly, to fulfill the first objective of the study, a sensor network is built. The Arduino sensor shield is fixed onto Arduino Uno. Sensor modules are connected to the sensor probes. Thirdly, the EC sensors are connected to the A1 of the shield, the sensor shield, ORP in pin A3, pH in pin A2, and DO in pin A4. The sensor shield is then connected with the Wi-Fi module, and the final picture is the complete system of water monitoring system. So to fulfill the second part of the objective, the sensor network is integrated with IoT. ThinkSpeak platform is the chosen platform to integrate the sensor network with an IoT technology. ThinkSpeak is an IoT analytic platform service that allows you to aggregate, visualize, and analyze live data streams in the cloud. You can send data to ThinkSpeak, like how I am sending the measurement from the sensors, and create an instant visualization of live data, which I would be showing in the next slide, and send alerts. I did not incorporate the send alerts part in this ThinkSpeak, but it will be recommended to be done in a future scope. In this section, I will illustrate the interfaces using the ThinkSpeak software. This is the interface of water monitoring system page to visualize the data in the ThinkSpeak website. This is the first two fields in the system, pH and DO. This is the third field, EC, and fourth field, ORP. The field can also be customized by editing the specification as per shown. Using the system, the preliminary results is taken, which is the day 1 reading. pH with 7.61 for slightly alkaline, DO with the average reading of 2.66 mg per liter. EC has mean value of 9.143 millisiemens per cm, and ORP has a reading of negative 418.783 milliwatts average reading. These are the labeled samples with the amount of concentration of EM in each samples being used. The minimum amount of EM being used is 10 drops, and the maximum amount of EM in the sample is 35 ml. From the graph, it can be deduced with the increase in EM1 concentration in the sample, the higher the corresponding pH reading. The second graph depicts that the dissolved oxygen content is decreasing with the increasing of EM1 concentration. The third graph, EC, did not show a consistent trend on the results when the concentration of EM1 is manipulated. The maximum value that has been recorded is 9.49 millisiemens per cm. And the final one is the ORP graph, and it can be depicted that the ORP value decreases as EM1's concentration increases. These are the reading being taken in the day 7 of the study. Results from the rest of the days are tabulated for the samples with the concentration of EM1 at 10 drops, 60 drops, 5 ml, and 35 ml, which is the first one, the 6th one, the 7th one, and the 13th one, according to the table that I have tabulated in the earlier samples table. So this is to visualize the data collected are clearer and easier to be understandable, as well as to be compared for the analysis to be made. So from the graph, you can see the higher the EM concentration, the higher the corresponding pH results. And it stabilizes with time, with 10 drops of EM1 having the most neutral results in the reading that has been taken. The figure above shows the results of DO reading, and it can be deduced that the level of dissolved oxygen decreases when the concentration of EM1 increases. The DO level decreases within the same concentration of EM1 as the duration of the samples are increasing. This graph shows the EC increases when the dosage of EM1 increases but decreases within the same concentration with time. The figure of this graph shows that increasing the amount of EM1 in the constant water sample will decrease the oxidation reduction potential of the samples. However, the ORP reading increases within the same concentration as the duration gets longer, with 10 drops of EM1 having the highest ORP at the end of the day. Data is summarized based on two concentrations of EM1 added, the minimum and the maximum. From the overall results, the most effective dose of EM1 to improve the quality of the lake water is 10 drops of EM1 to 1.5 liter of lake water, and 1 drop of liquid using a dropper is equivalent to 0.05 milliliter, therefore 0.03% of the sample volume. So as for the conclusion, the research objectives have been fulfilled. pH, DO, EC, and ORP sensors has been connected, and a network system is developed. The sensor network is integrated with ThinkSpeak to monitor the measurement in the website, which is the use of IoT technology. And finally, optimization has been carried out, and the most optimum EM1 concentration to be used in that lake water, which is the sample, is 10 drops of EM1 to 1.5 liter of the lake water, which is equivalent to 0.03%. So finally, let us move on to recommendation. In the future study, it is recommended to use more advanced microcontroller whereby there is a Wi-Fi module attached to the microcontroller itself to simplify the system and reduce the connections among the components. Not only that, secondly, there are several sensors being used can be replaced with a single sensor that has multi-parameter measurement. For example, only one probe is inserted inside the sample, but a few parameters are displayed. Thirdly, the study can be upgraded at the IoT section by using ThinkSpeak mobile application to monitor the water quality. As for now, there's only desktop version being used. And finally, a fixed amount of EM1 is to be added and the study to be carried out in the lake itself, which means monitoring on the site itself. That is all. Thank you for watching.